Okay, now you've been given that the line x is equal to 3 is the vertical asymptote. Find the value of c. So how do you find the vertical asymptote? You make the denominator equal to 0.
Yeah.
So cx plus 6 is equal to 0. So cx is equal to minus 6. So x is equal to minus 6 over c. And it's been given to 3. So obviously minus 6 over c is equal to 3.
Yeah.
So c is equal to minus 2.
Yeah.
Correct? That you got very well. Good. Write in the equation of the horizontal asymptote.
So 8x
Y is equal to coefficient of x in the numerator divided by coefficient of x in the denominator. So y is equal to minus 4.
Yeah.
Part C.
Yeah.
The line y is equal to k, where k belongs to a set of real numbers, intersects the graph of the mod fx at exactly one point. Find the possible values of k. Now with calculator or without calculator, just have a look.
With calculator.
Well, then it's very simple. Then you graph it.
I did, but the
So see what you. I'll show you. Now your fx which is there. You have 8x minus 5 upon minus 2x plus 6.
Yeah.
So you graph this on the calculator. You graph mod fx. Yeah.
I did that.
Graph this. Yeah. Graph y is equal to k. Okay, one second. So you type in the equation. So when you type in the equation, yeah. So option, nay, let me just show it there. Option numeric, correct? Absolute value.
Yeah.
Then you type in the function 8x. I want to show it in the video also so that people who don't know where the absolute is, they remember it. Huh? So minus 2x plus 6.
Yeah.
Correct? You graph this. View window, make it standard. You get a graph like this. Now what do you need to remember in this case is, now see what you need to remember, and this is the graph you got.
Yeah.
Now where will it intersect possible values of k? Now y is equal to k, technically is a horizontal line. Technically is a horizontal line. Now y is equal to k can take any value. Now if your k is let's say minus 7.
Yeah. How
many intersections are there if your k is minus 7?
0.
No intersection.
Yeah.
No solution.
No solution.
Over here, if it's here, what value? It will have one intersection here.
Yeah.
Correct?
So the minimum.
It's not the minimum though. It's not a turning point. It's a sharp point.
So the x intercept.
Yeah, it's the intercept. Now listen. Look, then we have to look at more solutions. Over here, there's a horizontal asymptote that will keep on rising, so it's not there. Over here, also there's a horizontal asymptote unless it goes up. So what you can do is you can check that. So one solution to we got equal to 0. Anywhere in between, it will have intersect once.
Yeah.
Anywhere in between, it will intersect once. So that means you need to get your, what is the intercept? Horizontal asymptote?
Yeah.
What's your horizontal asymptote?
Minus 4.
So now when it flips up, it will become y is equal to 4.
Yeah.
Correct?
Yeah.
And you get the minimum of this. So y is equal to, so basically if you zoom in, one second, so see, if you zoom out, you'll be able to see this. So basically y is equal to 4. It will cut at one point only. So 0 and 4. See, if you take 4, yeah, see, and if you try to do G-solve intersection, it won't intersect because that's your horizontal asymptote. It's intersecting only once. It won't intersect any other time.
Yeah, that's intersecting only once.
So you want intersecting once.
How do we know more than that? I don't understand that.
Because listen, what is your horizontal asymptote?
Minus 4.
And when you do modulus, what will happen to that modulus? It will flip up, na?
Yeah.
So what are the possible values of k? There are two possible values.
0.
Yeah. So k is equal to 0. Means that would be here. Correct. That would be here 1.
Yeah.
Correct. K is equal to 0, and this one would be k is equal to 4.
But what about 3? At 3 it won't intersect. It will intersect once or
It will intersect at 3. It will intersect twice, no? Because if you get this down, so see, you have your calculator, no?
Yeah.
So see, if you put 3 over there, see, it will intersect twice. 3 will intersect twice. You can do G-solve intersection.
Oh, yeah.
It will intersect twice.
Yeah.
Only for that horizontal asymptote it won't intersect.
Yeah.
So at an amusement park, a Ferris wheel with diameter 111 meters rotates at a constant speed. The bottom of the wheel is k meters above the ground. A seat starts from the bottom of the wheel. The wheel completes one revolution in 16 minutes. After 8 minutes, the seat is 117 meters above the ground. Find the value of k.
So K will just be
So after 8, so basically what's going to happen is, correct. 16 minutes means if it starts with t is equal to 0 over here.
Yeah.
So t is equal to 8, it will be at the highest point.
Yeah.
In
T will be
16.
8. How do you
It's half a period,
yeah.
na?
Yeah, no, after 8 minutes it's
See, what is it? 0. This is 16 over here.
Yeah.
So that means 8 it will be here, na?
Yeah.
Highest point.
Yeah.
And that height at the highest point is what?
170.
So height is that is 111 plus k,
Yeah.
and which is given to be 170.
Yeah.
So therefore k is equal to 6.
6. Yeah. And after t minutes, the height is given.
After t minutes, the height of the seat above the ground is given by this.
Yeah.
So that's a model which is given to you. ht is equal to 61.5 plus a cos pi 8t.
Yeah.
Find the value of a. So now a basically is the amplitude. You know that. You remember that?
Yeah.
How do you find the amplitude?
Max y minus min y upon 2.
Correct. Max y minus min y divided by 2. What is the maximum y?
170.
170. What is the minimum y? 6.
Yeah.
Correct? And that's your k. Minimum height is 6.
Because it doesn't go below 3.
It doesn't go below k. Absolutely. Divide by 2. So what is that? 111 divided by 2.
50.
2 5s are 10. 55.5.
Yeah.
That you got?
Yeah.
Achha.
And
When the height is 30, when the seat is 30 meters above the ground,
the value k and equate the equation
for the third time now. So what do you do is you graph it and you do it. Graph the model.
Yeah.
So now you have your calculator. So ht is equal to 61.5. A is 555.1. Correct? Cos pi t. You graph it and you do it. So exit, delete first everything which is there. Always clear your screen. Huh? That's very important. Many children do what, they keep on graphing on that only. And then they are totally confused. So 61.5. Plus 55.5. Correct? So cos. Now it's very important that you open the brackets and your calculator should be in radian mode. To this fraction, put pi x. See, type it like this: pi x upon 8.
Yeah.
Huh? Correct. You can do that also. Pi x upon 8. That's it. Now, what view window will you keep? Now, that's the main thing.
0 to 32.
Now, listen. View window when you're keeping, what is the minimum? So, view window. What is the?
They've given the domain.
What is the period? 0 to 32. Chalo. 0. Correct. 32.
Yeah.
What y value you will keep? What is the minimum height?
6.
Minimum height is 6. Maximum height is how much?
170.
So 120. You can keep some margin if you want. You will just be able to see that.
Yeah.
You got this?
Yeah.
Now can you see the? Acha, now exit.
Exit.
Now you 30 meters. So put 30.
30.
Y is equal to 30. So first time, second time, third time. So G solve intersect absolutely correct.
So 21.54.
21.5. So 21.5. The answer is how much? 18.5.
18.5. Yeah.
Oh, minus. Oh, okay. Starting from down. Your A is equal to minus 5. That's the mistake we made.
Why?
Your A, whenever it starts from down, it's minus 55.5. You put a minus sign. Because it's starting from down. So your cost graph should be starting from down.
Yeah.
That's I missed that part. Okay, so therefore we are getting a wrong answer. So instead of this plus, you put a minus sign. Oh, tricky, huh? Yeah, now you'll get it. Now G solve,
Yeah, 18.5.
intersect.
Yeah.
So first, second, third,
Yeah.
18.5.
Yeah.
So T is equal to 18.5. So in exams, you have to graph it and
Yeah.
show that this is
To
18.5.
graph it.
Yeah, if you're using a calculator, you have to graph it. You have to graph it like this and you have to show this.
So then there was one question I didn't get. Krishna said.
Okay, now see, look at this. Very important sum.
Yeah.
Is paper 1 or paper 2?
Paper 1.
Paper 1. So paper 1 is, so without calculator, so you have to do it without calculator. I've just resized the question so that you can see it in one frame. Consider a function f. The domain has been given from a to b over there. So from a to b, the domain has been given. The diagram shows the graph of derivative of f dash, the derivative of f. The graph of f dash, the derivative has x-intercept at x is equal to p
And T.
and 0 and t.
Yeah.
The local maximum at
Q
q
and T.
and t
And local minimum at R.
at r.
Yeah.
Local minimum at r. Okay, fine.
Yeah.
Find all the values of x where the graph is increasing. Justify your answer. Now, what is the condition for an increasing function?
Krishna, I agree with you.
You can write it if you want. You can just pay attention to this. No problem. You can
Yeah.
go home and you can try it out. So, what is the condition for an increasing function?
It has to be above the x-axis.
It has to be above the x-axis.
Yeah.
Yeah, but what is the condition on the derivative?
Greater than 0.
Correct, greater than 0. So derivative. So now, what is the condition for the function to be increasing? So f is increasing. It means that, implies that your f dash x is positive.
Yeah.
What does that mean? That means the graph of f dash x
It's above the x-axis.
is above the x-axis. Very good. Now, when is it above the x-axis?
From P to 0.
From p to 0. Correct?
Yeah.
So this is your justification. Part B. Find the value of x where the graph has a local maximum.
Local maximum. So Q. No?
So now local f has local maximum. When does f have local maximum? What is the condition for f having local maximum?
F dash is equal to 0.
F dash x is equal to 0.
Yeah.
And then one more condition. And
F double dash.
and if you have a sign change, for f dash, how should it be? Maximum means it should be positive and negative. Correct?
Yeah.
So where is the graph? F dash x graph, where is the graph going from? Now this is going from negative to positive.
Yeah.
This is going from positive to negative. Means at 0.
Isn't it going negative?
Huh? From positive to negative. No, don't look at the slope.
Oh, I don't look at this slope.
This is a slope graph. So here it is positive, and then it's the values
Just look
become
at
negative.
it above or
Above, below. Means it's going from above. So that means, I write it away. It means that graph of f dash x is going from above to below. Above means it's positive, to below is negative, below the x-axis. And where is that happening? This is happening at x is equal to 0. That's your answer.
Yeah.
So I'm writing the reasoning for you to revise, basically. Correct?
Yeah.
Then C1, find the values of x where the graph has a local minimum. So when will the graph have local minimum?
So what is negative and positive?
So f has
So 0 to t.
local minimum, implies that your f dash x is equal to 0, and this will go from what?
Oh, also
From negative to positive.
P
That means, what does it mean? It means that graph will cut from
below to above.
below to above.
Yeah.
Graph of f dash x will cut from below to above.
So when x is less than P.
So that is that at x is equal to p. Basically, in exams you have to just write. You have to write only the answers. Here you have to write the reason though. But these ones you have to write only the answers. This I am writing for your reference. Followed?
Wait, so local minimum won't it also be from 0 to t?
0 to t will be decreasing.
But it's going from
It's going from
below to above.
below to above. Correct. Now, where did it go from below to above? It didn't go any above.
Oh, it doesn't go above.
Yeah,
Yes.
it doesn't. It tries to go above, but it jumps back.
Yeah. So it's only from P.
It's only at p. Only one answer. Okay.
But won't you write then when x is less than P to
No.
give the range?
No. It should. Where does it go? Where does the f dash x graph
Start going.
cut from below to above?
Okay, below.
So that's only cutting. It's not. This is just bouncing back.
Yeah, so P.
So p is the only answer.
Yeah.
Absolutely. Find the values of x where the graph has points of inflection. Justify your answer. Now, what is the point of inflection? I've just repeated the same question. I repeated the graph here so that we don't have to refer to that. But just the same graph basically. Just repeat. Now,
Yeah.
now listen. Look. Your points of inflection. So, what is the condition for point? F has point of inflection. What is the condition for point of inflection?
F double dash is equal to 0 and F dash equals both.
No. Second order derivative is equal to 0 and sign change.
But both, even the first order has to be 0.
No, it may or may not be 0. Second order is 0.
Okay, fine.
That's for your
Horizontal.
horizontal point of inflection, both are 0. Now see, second order
The slope will be zero.
so basically when your second order derivative is 0 means your f dash x graph will have local max or min. It will have a local max or a local min. Where is it having a local max or a local min? At which points?
P and Q.
At P, at Q.
So Q and R.
Q, R and T.
Yeah.
At x is equal to Q, at x is equal to R, and at x is equal to T. Now there will be a difference. Now this is not asked, but there will be a difference. At Q, this will be your non-horizontal point of inflection.
Yeah.
At R also it will be non-horizontal point of inflection.
Mm.
But at T it will be horizontal point of inflection because that the first order is also 0.
Yeah.
Okay. Good question, huh? Very good question. The total area of the region enclosed by the graph of f dash, the derivative of f and the x-axis is 20. Now I'll be referring to now this. See.
Yeah.
So look, what is the total area now? Look at this.
Yeah.
This. Correct?
And from 0 to T.
This.
Yeah.
This area, the total area
It's 20.
is 20. Okay? Fp plus Ft is equal to 4. Okay? Find the value of F0. So this has been given to us. We have to find this. Now let's first write the expression for the area from P to 0. So let's call this A1.
Yeah.
What will A1 be?
Integration from
Achha, what is A1 will be integral from
0 to P.
P to 0.
So 0 upper limit and P is lower limit.
From left to right. P is always be negative. I mean lower to upper.
Okay.
Left to right.
Yeah, but 0 is the upper limit.
0 is the upper limit.
Yeah.
So but we write always in maths we say like this.
Fine.
I mean that's how you know. F dash x, correct?
Yeah.
Because your graph is f dash x dx. What is the integral of f dash x? F of x basically when you integrate it 0 to p, correct?
Yeah.
So that will be f0 minus what? F3. That's area 1. Okay. What does area 2 be?
Area 2 will be from 0 to T.
0 to t. But remember 0 to t when you do now, you will get the integration. And you will put minus of that.
So the under the curve, yeah.
Because it's below the curve.
Yeah. It's
Are you
on the
following?
x-axis.
So what will happen?
Mod it, no?
Mod it, but ultimately it will become minus.
Yeah.
Because if you find this area, if you find the integral, integral will be negative.
Yeah.
You negate the negative, so
Yeah.
you make it positive.
Yeah.
Basically, when you're modding it, that's the whole idea. So now what will this be? What is the integral of f dash x? Fx, correct?
Yeah.
Minus is there, t0, so that is minus ft minus f0, correct?
Yeah.
So that is minus ft plus f0. Huh?
Yeah.
So what will the total area be? Total area will be a1 plus a2.
Yeah.
The total area has been given to us. What is the total area? 20. Been given in the question above. So if you look here, the total area is given to be 20. Correct?
Yeah.
This you'll take this expression, put it here. F0 minus ft, and you'll put this expression. Are you following that?
Yeah.
I'm taking this expression, and adding them.
Yeah.
So that's minus ft, correct? Plus f0. Now if you don't change the sign now, you'll find your f0 will cancel out.
Yeah.
If you make that mistake. Now what you do is
2f0.
So 20 plus fp plus ft, yeah, I'm taking those as 2f0. Now they will give you fp plus ft is given to be 4. 24 is equal to 2f0.
So f0 is 12.
F of 0 is 12. Very important sum.
So,
Yeah, but only the thing is the integral is negative, so area will be negative of negative.
yeah.
That's the whole idea.
Yeah. And when you're finding area under the curve, you never do minus. It's always you always add the area.
You always add.
It's only minus inside the integration.
Yeah.
You never minus the curve.
You can. That depends on the question basically.
So when they have area and